Hi. In this video, we're going to continue looking at fractions. And what we're going to do is multiply and add fractions. So that's what we're going to do to continue lesson 3. I'd like to begin with when we looked at the problem that 3/6 is equal to 1/2. Because in there, we actually already learned how to multiply fractions. For example, or let's go back. We said that 3/6 is 3 times 1 over 3 times 2. And then we said that 3 over 3 was really just 1. And then we just broke it out. But really, let's just add that, keep that step in. It's 3 over 3, which was the 1, times the 1/2. And then we turn 3 over 3 into 1, and times 1/2. And we knew that that result is 1/2. But here is the real picture right here. Look at that. If you were to work this problem this time from the right side and go left, there's your answer. The answer is this, that you multiply straight across the numerator and you multiply straight across the denominator. So let's try that. You might be thinking, wow, it was right under my nose all this time. But it's kind of subtle, and so that's why we're going to try a couple examples. Here we go. Let's try one. Oops, let me go and do that and get my pen back. Let's try 1/3. And we can use the times 4/7. And notice, and just to be clear, that times can sometimes be written with this x, or it can also be written with this dot. And more often than not, as we go on, you'll probably see the dot more often than the cross or the x, because there's times when x is written about like that, meaning, and it means something else. And so getting this x not confused with this x can sometimes be a little difficult. So more often than not, we're going to use a dot for our multiplication. But in this example, it's pretty clear. So let's continue. Now, just like we said above, or found above, this says we just go across. And so that's what we're going to do. So this becomes 1 times 4 over 3 times 7. Well, we know how to do this. 1 times 4 is 4, and 3 times 7, that's 21. And that's it. We're done with that one. Now, let's try a problem that has another step inside of it. Let's try this. Let's try 3/4 times 2/7. Now, nothing changes. We go straight across. We're just going to go straight across. So we're going to multiply the numerator and the denominator. So I have a 3 times a 2 over a 4 times a 7. So 3 times 2, that's 6. And 4 times 7, well, that's 28. Now, wait a minute. Both 6 and 28 are even. So I can clean this up a little. I'm going to bring this down because 6 is the same as a 3 times a 2. And 28, well, that's a 14 times a 2. Oh, but look, those are common 2's. And so we can just cancel those because they just are 1, and multiplying by 1 doesn't change the value, just the appearance. And so we'd say that 3/4 times 2/7 is the same as 3/14. And the catch here is that 6/28, we say this can be reduced. Can be reduced. And sometimes you might hear, or simplified. So whenever you have a fraction, unless you're told otherwise, the general practice is to write it as reduced, or I should say reduced, or simplified, or in lowest terms. That's the standard practice. Okay? Now, let's try the same problem, but we're going to take a slightly more insightful approach. So let's try this. Let's start again with 3/4, and we're going to multiply that by 2/7. Well, 3 there can't be written as a product of other numbers other than 3 and times 1. So that doesn't give us any advantage, and 2 is the same kind of number. But 4, we could write as 4 times 1, but that doesn't change anything. But if we write 4 as 2 times 2, look at what becomes visible. Now, when I look closely, I see a common pair of 2's, both in the numerator and the denominator. So those cancel each other, and now I'm left with 3 over 2 times 7. Well, we already know the final result is 3/14. And what you'll find is if the numbers look like they're going to get big, then see if you can factor them, break them into products of other numbers first before proceeding. And this will save you oftentimes you can avoid some difficult multiplication. Okay, now we're going to take a look at adding fractions. And to do that, what I want to do is I want to go pick up our pretty picture up above. So I'm going to make a copy of this. And let's put it down here where we can work with it. Let's put it about there. Now, notice this. I have 13, or I should do that in orange. Let's do that in orange. So I have 13 out of 20 pieces that are orange. Okay, then I also have these pink ones, and I'm going to add them to that. But the question is how do I add fractions? So let's take a look at this problem more closely. Now, because all of the pieces are exactly the same size, really all I need to know is how many pink or orange pieces I have. And the most simple way to do that is just to start counting. And let's do that. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It looks like I have 18 of those. So the question is how would I get 18 20ths, or 18 out of 20? Well, a couple ways. Or not a couple ways, but here's how. Notice that the denominators match. And when you're adding fractions, this has to be the case. And when the denominators match, we call this a common denominator. Common denominator. And notice that when we were done counting all of our pieces, they were still in size 20. But we ended with 18, and you can see that if I took my numerators and I added 13 to the 5, I would have 18. And that's how you add fractions. Now, notice first that 18 20ths, those are both even numbers. And so I'm going to bring my 18 20ths down here. And I notice that they're both even. I have a 2 times 9 for 18, a 2 times 10 for 20, and now the 2's would cancel. In other words, my final answer is 9/10. Now, here's the key to adding fractions. They must, to add fractions, they must, that's an always, they must have a common denominator. Now, there actually is a way to add fractions when they have unlike denominators, but it's really not going to be a main part of this course. And when we do encounter such fractions, we're going to be using the calculator to help us accomplish that. But we do need to be comfortable adding fractions with a common denominator and then, if possible, writing them in their lowest terms. And that's how we multiply and add fractions. Hope that helps. Thanks for watching.